So we're going to review logarithms. So it would be really awesome if you remembered all this from Math 3, but if you don't, I got you. It's cool. We're going to go back through it all over again. And then there's extra resources on Haiku if you still feel like you need some more help on it. So your learning target is I can review logarithms. Okay, so first thing. A logarithm, all it is another way of writing exponents. So it's kind of the inverse of exponents. So logarithm looks like this. You're going to have a log with a little base. So it's a little subscript number. Let me just circle that. So, okay. And then you're going to have like a number you're taking the log of. And then it's always going to equal something. It doesn't always equal x. Sometimes it's a number, just a bunch of different things. Okay. So the opposite of a log is an exponential. And so exponentials, if you'll remember, you would have a base, you would have an exponent, and it would equal some number. So I try to color code it a little bit so you can see how they kind of go back and forth. And you read a log as log base b of a equals x. So if I had wrote something like this, I would say log base 2 of 3 equals x. So that's just how you'll hear me say it, and that's what I'm talking about. Okay, another thing that we talked about, you may not remember, is a common log. So a common log is a logarithm with base 10, and so it looks like this, but we write it without the base anytime it's a common log. So the only thing you need to remember is if you see this right here, it has an understood base of 10. Also, if you have a TI-84 calculator, when you see the word log on the button right beside the 7, that's a common log. And then there's another way to get to the other logs, and there's ways to do it on Desmos. So we'll talk about that later. Okay. So one of the things we did, I don't know if you remember from Math 3, we actually did like a zombie. We had to figure out how long it would take for the whole school turns into zombies. Anyways, so we had to convert between forms, so that's what we're going to do. So we're going to take log base 7 of 49 equals 2, and we're going to change it to its opposite form. Alright, so I'm going to do the base in blue. I'm going to do what we're taking the log of in yellow, and then the answer is going to be in red. So this is how you convert it to exponential form. Whatever the base of the log is becomes the base of your exponent. So 7 is the base of the log. That's going to be the base of our exponent. Whatever the answer was in red becomes the exponent. And then whatever you were taking the log of becomes the answer. And that's how you do those each time. So if we do the next one the same way, I'm going to do the base in blue, when I'm taking the log of in yellow, and the answer in red. So when I convert this to exponential form, whatever the base of the log is becomes the base of the exponent. The number by itself, the answer, becomes the exponent. And whatever you were taking the log of becomes the answer. Okay? And then we'll just work backwards from there. So the next two examples are already in exponential form. You know they're in exponential form because you see an exponent and also you don't see the word log. Okay, so we're going to write them in log form. Alright, so the base of the exponent is going to be in blue. My exponent I'm going to do in red. And the answer I'm going to do in yellow. So here's how you write it in log form. You have to write the word log or it's not log form. Whatever the base of the exponent is becomes the base of the log. The number by itself is what you would now take the log of. And then the exponent is going to be the number by itself. Same thing with the next one. You have to write the word log. The base of the exponent becomes the base of the log. The number by itself is what you take the log of. And then the exponent, and that was a -4, I kind of wrote over it, sorry, becomes your answer. So that's how you convert between forms. If it's in log form, you would put it in exponential. If it was in exponential form, you would put it in log form. Okay. We also talked about evaluating logs. So once again, there's that word evaluate, which means calculate, which just means that when you get done, your answer should be a number, not an expression. So we're going to use, we're actually just going to do this on our calculator. And we're just going to do this on the Desmos calculator because that's something everybody should have access to. So go to desmos.com/calculator. All right. And then you're going to click, if you see down at the bottom, there's a little keyboard button. And then after you hit the keyboard button, sorry, my pen's not working. If you'll click the functions button, and then after you click functions, if you'll click miscellaneous, and then right here, see it says log base A. It's a little hard to see. You can probably see it on your calculator better. That's when you use evaluating for logs. Okay, so now we're just going to type log base 6 of 36. And when you do that, you get equals 2. So very easy. Use your Desmos calculator. If we ever actually come back to school and maybe we're in school all the time and everybody's here, I'll still let you use Desmos calculators. If you are in the classroom and you would like to know how to do it on the calculator because you don't remember, just ask me and I'll show you. Okay, so now I want you, so this one equals 2. I want you to do the exact same thing for log base 2 of 128. So pause the video and actually go through those Desmos steps again and see if you can evaluate log base 2 of 128. 1, 2, 3. And you should get 7. Okay, so I'm going to show you something called the change of base formula because it is a big deal in pre-cal. Not that you guys would ever take pre-cal, but you might, who knows. So some logarithms are not as easy to evaluate as those above and will require the change of base formula. So I'm going to show it to you. You would just do the log of A divided by the log of B. The only reason you would ever use this is if you have a really old teacher that doesn't know that the calculator does log base other than 10. So there's really no reason to ever use this. Okay, and now we're going to do the last two. So we're going to approximate each logarithm. It says use the change of base formula. We're going to use that Desmos app because, you know, it's there and it helps us. Anytime it says approximate, you're probably going to have decimals. It's just a good rule of thumb to use at least 3 decimal places when you're talking about logs and exponentials. So I want you to pause the video, type these into your Desmos calculator, rounded 3 decimal places. Do that in 1, 2, 3. Okay, so for the first one, you should get 2.191, unless I've entered something in wrong, which happens a lot. And for the second one, you get 0.387. So these are pretty easy. So evaluate just means to calculate. Okay, we also talked about something called natural logarithms. So a natural logarithm is something that comes in, like it's just discovered naturally in nature and stuff. So if you have the log of a base E, that E is a number in math. And it's like 2.71828, and then this just repeats over and over. Kind of like pi. Everybody knows pi is 3.14. E is 2.7182818281828. So blah, blah, blah. Anyways, so whenever that occurs in nature, just as a shortcut to do the log base E, they shorten it to, this is called ln, but it's like a cursive L and then the letter N. And they do that. It's something about, oh crap, I don't remember. Back in the day when I was in college and took the history of math, it's something to do with the Greek language. I just don't remember what it was. If you're really interested, you can pause the video and go Google it. But we're going to continue on. Okay. So we're going to write each function in exponential form. So the only thing you need to keep in mind is an E and an ln, they kind of undo each other. Alright, so see how we have the natural log of x equals 4? If I wanted to get x by itself, I would undo ln by doing the e of both sides. So here's what I'm really doing. So e to the exponent ln x equals e to the 4th power. That's just how it works in math. And then an e and an ln, they cancel each other out. So the only thing left would be this x, and it would just drop out. So now I just have to type in my calculator e to the 4th power. If you're using a TI-84 calculator, the E button is found by doing second ln. If you're using the Desmos calculator, what I need you to do is just do 2.71828 to the 4th power. So that's how we're going to get around that. So if you'll put that in your calculator, and let's round to at least 3 decimal places. Either way you do it in Desmos or in an actual handheld calculator, you should get 54.598. So pretty easy. The second one works the same way. So to get, actually, see how the x is already by itself? All I need to do is type that in the calculator. So if you're using the Desmos calculator, if you go to Functions and you go over to Miscellaneous, there is an LN button in there. And then if you're doing it on a handheld calculator, you just type the LN button. And let's round to at least 3 decimal places. So we should get 2.303. I don't know why my decimals don't draw. Okay. Alright, so those are pretty easy. Alright, so now we're going to work backwards. We're going to write each equation in logarithm form. So just keep in mind, an E and an ln cancel each other out. So if I wanted to get rid of the E, I would do the natural log of both sides. So here's how it would look. And so the nice thing about an E and an ln is they just cancel out, and the only thing left on that left side would be the x. So x equals natural log 30. So then all you have to do is type that in your calculog. Calculog? What is that? Calculator. Okay. And then we're going to round to 3 decimal places. So I'm going to call this 3.401. Same thing on the other side. X is actually already by itself. So all I need to do is put this in my calculator. Remember, if you're using a Desmos calculator, just keep in mind that E is this number. And so just type this into your Desmos calculator and you'll get the same thing. If you're using an actual calculator, then you can just type in E to the 0.5 power. Either way, you should get 1.649 if you round to 3 decimal places. Okay. Alright. And then if we're just approximating the value, approximate and calculate and evaluate all kind of mean the same thing. All you're doing is just putting that in the calculator and rounding. So if I type in natural log of 64, remember to use 3 decimal places. I'm going to do my, this is like an approximation symbol. It also means equivalent. So I should get 4.159. I do the next one, the natural log of 1/3, and I'm round to 3 decimal places. I get negative 1.099. Okay, pretty easy. Okay, so let's just go over what we went through, because it was a lot, I know. We would have done like this over like a week's time in Math 3, so we're just reviewing. So we talked about changing from log to exponential and back. We talked about how the common log is just a log with a base of 10, so if you don't see a base, it's understood 10. We converted between the forms. That's a big deal. Make sure you know how to do that. We evaluated logs. All you had to do was type it in. You can use the Desmos calculator or an actual handheld calculator, excuse me. I'm running out of air. And then we talked about natural logs. So just remembering that an E and a natural log work to cancel each other out. So if you see a natural log and you want to get rid of it, then you're going to E both sides. If you see an E and you want to get rid of it, you're going to natural log both sides. And then remembering that approximate, calculate, anything like that just means give me a number answer. And anytime we do this, just a good rule of thumb to round to 3 decimal places. Alright, so hopefully this video made sense. If not, you can always message me for help. Bye!